everyone, welcome back to our channel. So my name is Preeti Gupta and in the last video we discussed array, what they are, why need them and types of array, and last we discussed CRUD operations in array, right? So I hope you understood the things, and if you have any query in previous sessions, please let me know and please comment on chat box. Okay? So before move into searching algorithm like linear search, binary search, sorting, we must understand one of the most interviewed topic like time and space complexity. I already this previous session I already said like in today I will discuss linear search, right? So I'm so sorry for that because I forgot time and space complexity because it's very important to move forward in when we have to like learn linear search before we know the time and space complexity. Okay, it's very important for interview also. So let's discuss what is time and space complexity? So simple, we know time complexity means what? Tell us how much time an algorithm take as input size grow. Means they said how much time they take in this algorithm. So this is called a time complexity, not in actual second. This is not an actual second like real life example like they go into the second nothing. This is not actual second. This is but how fast or slow the code become when data structure we have to use. Okay, so how time complexity is very matter. Okay, so time complexity is what? time complexity Time complexity tell us how much time an algorithm take an input size grow. Okay, that's called a time complexity. Okay, so space complexity is what? Space complexity simply tell us how much extra memory we use in our algorithms. This is the part of our input. Like when we have taken an input, we have using some extra memory or not. This is called a space complexities. Okay, let's discuss some analogy. Then I think you feel good and you understood the things. Like searching your friend in a quick means like they have 10 people and we just check it in 10, right? 100 people, we check it 100. More like more than 100, then check it more time, right? So they take 10 people they take less time, then 100 people they list more time little bit instead of 10 or more than 100, right? More people less than 100 or 10, right? So this is the time complexity of vigo of one. How? Because their time complexity increases of the input size, right? Because 10 people check 10 times, 100 people check 100 times, more people mess more than 100, then more times, like so their time complexity is changing on the peoples, like how many peoples they are there means their input side. So that's why this is called a big O of n. We can call that a they taking time of a big O of n time complexities. Okay, so let's discuss of finding a word in a dictionary. Like we, when you have read some dictionary, when we have find some word in a dictionary, we jump into the middle and skip half, then again half. It's a very fast, right? This is called a big of log n. Like rather than big of one is slow, like they're in depending on input size, but big of log on is very fast instead of big of n, because we just jump to the middle, then skip half, then again half, then they find it what? Fast. So that's why they taking time of what? Big of log n. Okay, so this is called a time complexity. Space complexity means what? Like for example, study tables, one notebook is there. Okay, So one notebook is like means less time, they constant time, they only one notebook, right? So this taking only one, like only notebook or only notebook is there in your table, means they taking less space. Okay, because they constant space, they are not taking extra space. Okay, if you are in your study table, they we have a 10 notebook, then they taking more space, right? So that's why they are using big of n times, means they are depending upon what, input size, means they are depending upon of notebook. So that's why they are taking a space of big of n. So let's discuss another, like more book means more needed, similar to the program using extra array. Okay, like we have to using more book, means more space is needed. If you are using less book, like only workbook, they needed only constant time, they using only constant time. If you are using more book, they using more space needed. So similar to the program using, if you are using extra array, they taking we go of n times of array, space. Okay, let's do the some practicals code, then I think we understood the things. Okay, well, I am sharing my screen and hope you got the thing. Hope my screen is visual, right? So let's say we discuss first question, like we create a one functions. Okay, and the inside we using n, means number of argument we using. Okay, and we traversing to the n of the length. Okay, and we just print it I, simple. Okay, so tell me how much time complexity of this code, it's constant or it's a big of n? Of course it's big of n, right? Because I already discussed some analogy, like they are taking n times. If you are printed okay, if your input is 5, they print it 5 times, right? They printing 5 times, means depend on the number of the input. That's why they're taking big of n times. Okay, if you are like if you're increasing something like 5 to 10, they depending upon what, input size, they depending upon input, they depending on input size of n. Okay, that's what they taking big of n. Okay, let's discuss another questions. See, we create a one array and we have a 10, 20, 30, and 40, and we printed. Okay, I just comment these questions. Okay, we printed ARR of 2. We printed ARR of 2, means accessing element does not depend on array size, because they are accessing what, they are accessing index of 2. Where is index of 2? 0, 1 and 2 means 30, right? So they accessing an element does not depend on the array size, they are do not depend on the array size, right? So they are always a constant time. That's why they're taking big of 1. They're taking constant time because does not depend on array size. Okay? Okay, if you have confusion on this, Please let me know. Okay. They are depending on what? Don't depending on area of size. They just printed indexes. That's why they they taking Vigo of 1 means constant time. Vigo of 1. Okay. Let's discuss these questions. See, they are using nested loop. Like nested loop say what? First loop they go to the 0 to n times. Second is j is equal to 0 to n times. So I is also depend upon input size and j is also depend upon input size. So first outer loop is depend on input side means they taking we go of n times, and j inner loop also depend upon n size means input size. So they is also taking we go of n times. Their time complexity is what? N into n means we go of n square. So nested loop means very slow and time increases. So time increases means it's very fast. So it's not good. It's a quadratic time they are taking. Okay, quadratic. So they taking quadratic time. So it's a using Vigo of n square time complexity. Vigo of n square means oh, quadratic time. Okay. Simple we absorb the how they are taking the loop and the how. Okay, let's discuss the space complexity. See, uh, in a space complexity, only one extra variables, a space stay constant. They are taking only one extra variables means sum. Sum is the 0. They are taking only extra variables, right? So that's why they are taking a space stay constant. Okay, because they are not creating extra variables. They are taking only one variables whose is 0, like which variable is slide in 0. Only extra variables is what? It's a constant, right? So that's why they is a space stay constant. Okay, they're taking only extra no, they are only create a like sum, simple sum we created, right? That's why they are taking a space is Vigo of constant with Vigo of 1. For these for this code, see, we created another equal to size n. See, we created a let new arr equal to means a space means something a space we just created. So new array created, right? So if you are creating a new array, so new array we have to create it equal to the size of n. Okay, new means you we created another array size equal to the they are equal to the size n means need extra memory. Okay, they are taking extra memory. That's why we their time complexity was big of big of n. Okay, that's why we have taking big of n times because we created another. array, this new created array, and this array equal to the size of n. So need extra memory of big O of n. Okay. Hope you got these things. We just like analyze the things how time and space complexity working. Okay. So interview always asks what is time and space complexity of your solutions. Like if you're doing the some code and they are asking what is the time and space complexity they taking. So we just explain it. Okay, they taking this for if you are using nested loop, they taking to they taking big of n square. It's a very fast and it's a very slow because they are taking they are taking to a nested loop. So if you are taking nested loops, it's very slow, right? So what is space complexity? Space complexity because we allocate some memory. The memory then they allocate it as like constant. Then we have to use in constant space. If you're using some extra array, creating creating extra array, then they are needed as a extra memory. Okay, so a space complexity basically defined as a memory. Okay, so time complexity, how fast your code runs. Space complexity means how much memory code uses. Means this make you better problem solver. Okay. So today is that's all I think. So today we clearly understood time and space complexity using analogy and coding examples. In the next video, we will start with linear search, dry run, plus code plus logic building like and if you are like our channels, please like, share and subscribe to our channels. Keep learning, keep improving and don't waste your times. Bye bye, take care, have a good day.